Hi, this is Miss Litton, and this is lunchtime with my lovely honors biologist. Say hi.
Hi.
And we are reviewing Chapter 2, the molecules of cells. It's a huge chapter. So I'm going to just hit the highlights through the chapter briefly, and then I have a ton of questions, quicker questions I want to ask you to make sure you understand it. So I want to start off with CHNOPS. What is CHNOPS? Remember that? Carbon, hydrogen, what? Nitrogen, oxygen, phosphorus, sulfur. Why do we even care about CHNOPS? Those are the most common what? Elements in living things, okay? And when we talk about states of matter, that's super easy. What are the states of matter? Solid, liquid, gas, and most matter is actually plasma. Good. All right, then that brings us here to the atom story. Ready? Let's do it together. The atom story. Atoms are made of
Protons, neutrons, electrons.
the
Protons, neutrons
are in the nucleus, atomic mass. The electrons are in energy levels. 2,
8, 1832.
do that again. 2, 8, 1832. 8, 8, 8 is great. Octet rule. So we know charges, we know where they're located. Okay. Can I vary any of those numbers of an atom? Yes, I can. What can I vary?
The number of
Neutrons. Good. If I vary the number of neutrons, then what is it called? An isotope. What else can I vary? Electrons. And then what is it called?
Ion.
Ion. Good. Ion and isotope, you got that down. Next, when you have elements and you want to talk about where everything is, you could tell me from right here, looking at this from the periodic table, let's talk about all the things you could tell me. You could tell me the number of protons. Because the number of protons is always the what? Atomic what? Number. Okay, and that's equal to the number of protons. Perfect. Okay, what else could you tell me? Neutrons. How are you going to get the number of neutrons? Right here. This is called the atomic mass. And it's the protons plus the neutrons equal the atomic mass. So if I know the atomic mass in this case is 35 and the number of protons is 17, then what must be the number of my neutrons? What did you say? 18? Does that add up to 35? Yes? Now, what else can you tell me? Number of electrons. Because if you have a neutral atom, however many positive charges you have, you usually have the same number of electrons. If it's not neutral, if it's got a charge on it, it's called a what? Ion. And that's because it's either or electrons. What? Gained or lost. Okay? So if I want to put electrons away, there are energy levels. Tell me the energy levels. 2,
8, 18, 32.
Good. All right, how many electrons do I have to put away? 17. How many can I put in the first level?
2.
How many can I put in the next level?
8.
How many have I taken care of?
10.
How many do I have left?
7.
7, because 2 plus 8 plus 7, right? Now, and this is all of chemistry. Why does one atom interact with another atom? It wants to get stable. Okay? How do you get stable? You either fill up all of your energy level, your outermost energy level. Okay, fill it up, or you get it to what? 8. Either fill it up or get it to 8. 8 is great. What is that referring to? Octet rule. Okay, fill it up or get it to 8. Now, this particular level will hold 18. What do you think is the most likely scenario? To go out and find 11 electrons to fill it to 18? No. Yes or no?
No.
No. To ditch 7 of those electrons and get it down to 8?
No.
No. What do you think you want to do?
Get one more.
Get one more electron. Now, there are ways to get electrons. What would be the kindly way to get an electron? Share. What kind of bond is that when you share? Covalent bond. And there are two kinds of covalent bonds. Okay? When you share fair, right? Share the electrons equally. What kind of covalent bond is that called? Non-polar covalent. When you share unfair, that's called polar covalent. When one hangs on to the electrons more than another. Okay? Let's say I just don't like sharing. I'm not a sharing kind of person. Okay? I want my own. Okay? If I go out and do what to an electron? Steal an electron. Now I'm happy, yes? But what's the consequence of my stealing behavior? I have a what? Charge. What's my charge? Negative. But I am happy because I have 8 valence electrons. But now I'm negatively charged. Who will I always be attracted to? Positive. And that's how atoms build what?
Bonds. Molecules.
Molecules. Good. Atoms build molecules. Good. Okay. Now that's hard. Okay. When we looked at the periodic table, when you go horizontal, you're referring to your period. I know what you're thinking. Right? Does that not help? Okay. And when you go vertical, you're in a what? Group. And when you're in a group, you have the same number of valence electrons. So they all have 1, and then this group all has 2, and this group all has 3 valence electrons. Yes? And then when you go across this way, this is, if I put there, it's atomic number 3. So he's 2, comma 1. He's 2, comma 2, 2, comma 3, right? So we're all working out of the second energy level for that period. So if we're in the second energy level for this period, what energy level are we in this period? First. Okay, so he's just 1, and this one's just 2, right? How is hydrogen 1, by the way? Because he only has one
in the first
proton and 1 electron, right? So his atomic mass is still 1 because he doesn't have any what? Neutrons. Perfect. Okay. Good, good, and good, and good. We talked about isotopes. Happy, happy, happy. We'll do that at the end. We did bonds. Happy, happy. All right, let's talk about water. Okay? When oxygen binds with hydrogen, does the oxygen share the electrons in their covalent bond fair? No, they share it what? Unfair. So what kind of bond is that?
Polar.
Polar covalent. So as a result, the oxygen becomes slightly what? Negative, and the hydrogens become slightly positive. So when you have a bunch of water molecules hanging out together, when they're interacting, one molecule to another molecule, this right here, his partial negative to this one's partial positive, this bond right here is called a what bond? Hydrogen bond. Okay, what is this bond in here called? This is a hydrogen bond here, but that bond right there is called a what? Polar covalent. Good. Do you understand what I just did there? Make sure you get that. Okay. And I'll ask you a bunch of questions about that. Hydrogen bonds hold DNA together. We looked at different properties of water. Things like it can moderate the Earth's temperature because it can hold all those energy in those hydrogen bonds. High heat capacity, right? We talked about it being a good solvent for those things that are hydrophilic. We talked about these two terms. Let's go over this, adhesion and cohesion. Okay, if you have a co-worker, right, that's somebody just like you, a co-worker, right? Cohesion is water to water, okay? So that's between water. Think like co-workers. We're same. Whereas adhesion is when water molecules attach to some other polar surface. Adhesion, like tape, right? You don't want tape to stick to tape. You want tape to stick to something else. Adhesive, yes.
Is it just between water?
No, you can form hydrogen bonds between other things as well. It's just they're still called, hydrogen bonds, good. And we talked about surface tension, and we also talked about that frozen water is less dense than liquid water because all their hydrogen bonds are equal distance. Okay, then we finished it up talking about pH. If you have a low pH, what do you have a lot of? Hydrogen ions, and you are classified as an acid. If you have a high pH, you have more hydroxide ions, less hydrogen ions, and you are classified as a base. Okay? When you change from 5 down to 4, what is the difference in the concentration of hydrogen ions?
10 times.
10 times. If I went from 5 down to 3, it's 10 times 10, so it's really what? 100 times. Okay? Perfect, perfect, perfect. Okay? We talked about carbon. How many bonds does it like to make? 4. Okay? We talked about because 2 come 4, right? Okay. We talked about hydrocarbons, which are primarily carbon and hydrogen. We talked about how monomers build polymers. And when you see the word macromolecule, that would be another way of saying a polymer. Okay? Macromolecule is just a large molecule. A polymer is made out of like a bunch of little subunits, monomers, like a bunch of sugars forming a carbohydrate. And we talked about that there are 4 important organic molecules, and here they are. What, you need me to go back? What did you need me to go back to?
What is another word for polymers?
Macromolecule.
Okay.
Okay, so if I'm talking about these here, okay, if I was talking about carbohydrates, these are the polymers. What would be the monomer for carbohydrates?
Sugars.
Sugars. Okay, in a nutshell, sugar. Could you think of a picture to represent sugar? Think it in your head. Describe it to somebody next to you. Something like that? Yes. Now, if I want to take individual sugar units and build carbohydrates with them, the 2 sugar units were fine all by themselves, but I want them to hook up. So what do I need to do to make them hook up? Because they're happy right now. Dehydration synthesis. What do I need to take away from them? Collectively a water molecule. Hydrogen from one and OH from another, so that they have needs and they meet their needs with each other. Right? That's how I join them. If I want to break them up, what's it called? Hydrolysis. We learned about carbohydrates. We learned about different kinds of monomers. Do you remember the different kinds of monomers? Yes, glucose. What was another one? Fructose. Good. What was another one? Galactose. You are so right. Okay. If you put glucose with another glucose, what was it called? Maltose. Glucose plus fructose gave you sucrose, table sugar. Glucose plus galactose gave you lactose, milk sugar. Those are all, when you hook 2 sugars together, what is that called? A disaccharide. Okay? We broke carbohydrates down, right? In polymers, there are 2 main functions of those polymers. What are the 2 main? Energy and what? Structure. All right. How you store your energy is different depending on if you are a plant or an animal. How do you and I store our energy? Glycogen in our what? Livers. Good. How do plants store their energy? Starch. Good. Okay. So glycogen in our livers, starch in plants. Structure. Do you remember the different structures we could build with carbohydrates? Cellulose, plant cell walls. Good. What else? Chitin. Good. Fungal cell walls and arthropod exoskeletons. That bit right there, my friends. Okay? That is all right here in your little summary. Dun, 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 dun. Here. Right? Sugar, glucose, fructose, galactose, maltose, is I told you what each one of those are, and that's all right there. Do you have that already? Yes. Okay, that summary is there. Okay, now let's talk about lipids. Okay, talk about lipids. What are the two kinds of lipids you could have? What? Steroids and what? Fats or triglycerides. Remember, fats are it's a glycerol with the long fatty acid chains. Remember that? And these fatty acid chains could be what? Two categories. Saturated or unsaturated. Okay? We said if they were saturated, you would usually find them where? Animals. And at room temperature, they are a solid. And unsaturated is plants. And they are a liquid. Okay, and we talked about how you could modify them into phospholipids in cell membranes. Steroids, remember, are made out of what? I drew it poorly, but 4 what? Rings of carbon, like testosterone and estrogen, right? Okay, and we talked, and we looked at our summary of this. It was a little something like this. Lipids, fatty acid chains, which are right there, could be saturated or unsaturated with glycerol. This is the glycerol, and here are the steroids. And we talked about energy storage, cell membranes, steroids like cholesterol and hormones, waxes are waterproofing. I mean, it's not like hard on that. Oh shoot, sorry. I'll turn off my telephone now. All right, next we talked about, sorry. Proteins. What are proteins built out of?
Amino acids.
Amino acids. So amino acids have a central carbon, yes? What else do they have? They have a hydrogen. What else?
An R group.
R group down here, yes. What else? A carboxyl group and an amino group, yes? Okay. Now, there are 20 different amino acids because there are what? 20 different R groups. Some of them are hydrophilic and some are hydrophobic, right? And so that, when you start hooking amino acids together, you do it the same way, dehydration synthesis, but there's a special bond between this nitrogen, oh sorry, I'm disabling him, this nitrogen and another amino acid's carbon. What kind of bond is that? Peptide bond, okay? And protein structure is very critical when it folds and everything to its functionality. Remember we talked about that. That was important. Okay, and we have all of that right here. Right? Proteins are built out of amino acids, and you see them as muscles, messengers, antibodies, enzymes, etc. Okay, that brings us to our last one, so we can start doing some clicker questions. Nucleic acids. And nucleic acids are built out of what? Nucleotides. Okay, stop. Okay, a nucleotide. And what is a nucleotide? What 3 things do you have for a nucleotide? Phosphate group. Phosphate. What else? Sugar and nitrogenous base. Good. Then we talked about differences between DNA and RNA. Yes? Okay. Is the phosphate part the same? Here, I'll add the other one on here. ATP. Is the phosphate the same?
Yes.
Yes. Phosphate, phosphate. And here in ATP, how many phosphates do you have?
1.
3. Adenosine triphosphate. Right? But they all have phosphates. Okay. What about the sugars? Are the sugars the same?
Yes.
What do you have in DNA? Deoxyribose, hence the name DNA. And in RNA you have ribose. What do you have in ATP? It is ribose. Okay. What bases do you have in DNA? You know them. Adenine. What else do you have? Adenine. What else? Guanine. Cytosine and thymine. Good. Do you have adenine in RNA? Yes. Do you have it?
Yes.
Do you have it?
Yes.
Do you have it? No. What do you have? Uracil. Good. Okay, and there's adenine. and ATP. Who binds with who? Adenine binds with thymine. How many hydrogen bonds? 2 hydrogen bonds. Guanine binds with cytosine. How many hydrogen bonds? 3 hydrogen bonds. DNA is double-stranded. RNA is single-stranded. Good? Okay, and then, can I leave that? Everybody happy? Okay. Yes?
What is like ATP?
Oh, adenosine triphosphate, that's your energy currency of the cell. Yes, and here, I'll go back to that.
ATP.
So when you break a bond, when you snap off one of those phosphates, so instead of being ATP or ADP, adenosine diphosphate, when you do that, you get a bunch of energy. Okay. So, and then that is represented here. Nucleic acid, here's a nucleotide, genetic code, protein synthesis, ATP energy. That's the whole thing. And that's Instagram too. Yes?
So ATP is a nucleic acid, but it's not a nucleotide.
No, it is a nucleotide. All nucleic acids are built out of nucleotides. Yeah, it's just one nucleotide, and it's base, sugar, phosphate, phosphate, phosphate. Are we good on that? So I can start questions now? Okay. Now, based on the, well, we'll see. We can do it. It's number 23. Number 20. Now, I'm not going to give you a lot of time because I want to get through all of these. Okay? And I have, like, how many did you say I had? I had a bunch.
You had a lot, like 17 or something.
17 of them? Yeah, you're totally going to be ready for your quiz. Let's go. Five, 4, 3, 2, 1. Oh, what did somebody say? E? No. Most of you got that. Amino acids build proteins. Let's go on. Next. Five, 4, 3, 2. Oh no. Oh. 4 rings of carbon. 4 rings is always going to be a steroid. Okay, 4 rings is steroid. You will always be my first mom. Five, 4, 3, 2, 1. Let's go. Disappear. Let me click off it and come back. Yay! 1. Okay, good job. Here we go. Why do those water molecules hang on to each other between your fingers? Due to what? Cohesion. I don't know why it's taking so long. Oh. Oh.
Vibrational movement.
Did I even use that word? No. No. For shame. Don't say it out loud. Let people think. Five, 4, 3, Chaka Khan, what is that? That is an amino acid. Okay, amino acid. Central carbon, carboxyl, hydrogen, amino group, R group. How many different amino acids do we have? 20. How many? 20. Check your Bio Buddies clicker, chastisement or praisement? Don't celebrate your ignorance. That's good. 5, 3, 7, 2. Ah. Okay, let's help this person who picks steroid. How many rings would we need for this to be a steroid? 4. Come on, come on, come on. 5, 4, 3, 2. Wait, it missed it. It's wrong. Nucleotides build what? Nucleic acids. I'm so sorry. Okay, guys, I want to blaze through these. I'll just say them out loud because you only have 10 minutes till your next class. Saturated fats are solid at room temperature and come from plants. True or false? False. False. Why? Okay. The chemical reactivity of an atom is dependent on C. The number of electrons in the outer shell. That determines how reactive it is. Say if you're leaving, you guys, leave quietly, don't talk, because we want to go through these so you get hundies on your quizzes. This is a map question. So when you do dehydration synthesis using 2 amino acids, will you form a protein? Yes. When you do dehydration synthesis using 2 amino acids, will you form a water molecule?
Yes.
Yes, dehydration synthesis. Using fatty acids and glycerol, you will form a nucleic acid. No, why not? What would you form? Lipids. Good. When you do dehydration synthesis using 2 polymers, you make a monomer. No, you would have to reverse this, right? Using nucleotides to form a nucleic acid. Do nucleotides form nucleic acids? Yes. Yes. 2 freshmen to form a sophomore? No. An example of hydrolysis would be building amino acids from proteins. Do you build amino acids from proteins?
No.
No. Do you build lipids from fatty acids and glycerol? Yes. Do you break down glucose into starch? No. When you see the word hydrolysis, what is that about? Building or breaking? Hydrolysis is breaking, okay? So if we're going to do hydrolysis, it's got to be breaking words. So let's go back to that because I don't know what I was saying originally. When you're doing hydrolysis, it can only be the breaking. Building, you do, you're not going to do A because that's a building word, right? So I'm crossing this out. I don't even care what this says because this says what?
Building.
Building. Okay, these are the 2 breaking ones. So breaking down glucose into starch. Does glucose break down into starch?
No.
No. Does starch break down into glucose?
Yes.
Yes. So your answer is D there. Now, the name DNA, what sugar separates DNA from RNA? Deoxyribose. So any of these that have the word ribose in it, we can cross out, right? So who can we cross out?
A.
A. Who else?
C.
C and what else? E, because it's got ribose. So you only have B and D to choose from, and what does B have in it that you?
Uracil.
Yeah, so we're going to cross it out. So do you see the logic of how we picked that?
Yeah.
Okay. What is hydrolysis? Breaking. So when we break, you produce what? Do we produce sugars?
No.
Do we produce fatty acids?
Yes.
Yes. Because a fat is made out of glycerol and fatty acid chains, right?
Yes.
Okay, so we produce fatty acids. Do we produce nucleic acids?
No.
No. Glycerol?
Yes.
Do we produce water?
Yeah.
No, we have to use water to break them up.
Yeah.
So water's not a product, so no. Do we produce oils? No. No, we don't. Okay? What type of molecule is that? Steroid. Oh yeah, okay, we did that one. Which of the following is a DNA nucleotide? Is this one different?
It's the same thing.
Oh, it's the
Same
same one?
thing.
Okay. True or false? That's true. Yeah, that's true.
Wait.
Because it's between the slightly positive hydrogen of one molecule and the slightly oxygen of another. Slightly negative of, yeah, the other, which is an oxygen. An example of a dehydration, that's a building one, right? So who can we cross off? C and D, because those are breaking. I don't even want to look at it. Now, do we build amino acids from proteins? No. Do we build lipids from fatty acid and glycerol? Yes. Okay, we've done one of those. I don't know what I'm doing. Is that a hydrogen bond right there?
Yes.
Is that
No,
picture showing a
no,
hydrogen bond?
No.
No, what's that bond right there that it's pointing
Polar
to?
covalent.
Polar covalent. That is not a hydrogen bond, right? A hydrogen bond would be if I had another water molecule like this, right? And a hydrogen bond would be like here. Do you see the difference?
Yeah.
Okay. Oh, make sure you do your additional objectives too. Okay, good job, you guys. Super proud of you. Good study. Do your additional objectives. If it's 11 o'clock at night, you should be going to bed.
Go make a
No, you
piece of
shouldn't.
toast.
Go make a piece of toast. I do say that all the time because that always sounds good.
Study for 15 more minutes.
Study 15 more minutes to get a piece of toast. Love
Go get a
you.
snack.
Yeah.
Shut up now.
I
Just a minute.